friends. Hello, friends. It is I, Mr. Covey here. This is 10.3.48. Let's talk about it. So it is giving you this parametric, and it is asking you to determine the open intervals on which the function is concave up and concave down. Concavity has to do with the second derivative, and they give you an interval of t values. So I'm going to find dx dt and dy dt. Check, I already wrote this out. So here's dx dt, there's the dy dt. I'm going to stack them. dy dt over dx dt. Simplify. That's dy dx. It's my first derivative. To find the second derivative, you have to do the derivative of dy dx and then stack it on top of dx dt. Okay, so I'm going to do the derivative with respect to t of dy dx. What's the derivative of negative 1/2 cotangent? Well, the derivative of cotangent is negative cosecant squared. So I'm going to do negative 1/2 times negative cosecant squared. Oh, that's just 1/2 cosecant squared. And then you have to stack it over dx dt. Don't forget to stack it over dx dt part. And that gives me my second derivative. Now here comes the tricky part. This is the reason I think you guys are asking about this. If I want to figure out where it's concave up or concave down, I need to figure out where the concavity is changing. So how could the concavity change? Well, maybe I have some points of inflection where the concavity equals 0 and it switches from concave up to concave down. So I think about thinking about when, come on, Mr. Covey. You think about when the second derivative is going to equal 0. You think about this equation, and you math. And you go, when is cosecant equal to 0? Don't happen. It don't happen. So the second derivative never equals 0. So then you're like, is it just the same all the time? Don't forget to check where the second derivative is undefined. Okay, that's kind of the tricky part here. So where the second derivative is undefined could also be a time when the concavity changes. When would negative 1/8 cosecant cubed of t be undefined? Well, when is cosecant undefined? Well, it's when sine is 0. When is sine 0? At pi. So at t equals pi, the second derivative is undefined. So then when I go to make a little chart, a little concavity chart, the second derivative is never 0 between 0 and 2 pi. Silly Mr. Covey. But at pi it's undefined, so it's possible the concavity changes there. So I'm going to make a little chart like this. I'm going to pick a t value in here. I'm going to pick a t value in here. I'm going to pick 3 pi halves in here. I'm going to pick pi halves in here just to make it easy. I'm going to toss them into the second derivative. I'm going to get negative here and positive here, which means it's concave down when t is between pi and 0, and it's concave up when t is between pi and 2 pi. That concludes this video. Thanks for watching.